Hello everyone. Today I'm going to show you how to detect the state of charge of this lithium ion cell. Here I have a lithium ion cell of 1200 milliampere hour, and as we know that the nominal voltage of this is 3.7 volts, and we are going to detect the state of charge by the open circuit voltage method. Okay. So you guys might be thinking, how can we detect the state of charge of the cell by just calculating its voltage? So we are gonna do it like this. Uh, we are gonna detect the voltage of the battery through this microcontroller, through this ADC pin, and convert it into the equivalent voltage, and then assign that voltage to some state of charge, like 4.2 is 100%, 3.9 is 90% in the code. So first you have to check the voltage of the cell. So I'm getting it as 3.90. Okay, we got to know that the voltage was 3.90, and to detect this voltage by microcontroller, we know one thing, that this microcontroller only works on 3.3 volt, but the voltage we are getting is 3.9. So what we are gonna do is, we are gonna divide the voltage by the voltage divider rule. This is the voltage divider rule. Here the Vin is given as 3.90, and these are the two resistors of the same value, that is 1 kilo ohm and 1 kilo ohm, and here goes the output, and this is connected to the ground. So our output is equals to Vin multiplied by R1 divided by R1 plus R2. That becomes this value, 1.95. So our given voltage was 3.90. Here it is almost half. Connect the cell to the voltage divider circuit, and now we see how much voltage we get. So we are getting 1.94 volt. That is exactly what we want. Connect the microcontroller ADC pin, that is D34, to the output positive, and ground to the ground. Before jumping to the code, we guys know that microcontroller pin can only read the ADC value equivalent to the voltage given. So to know that equivalent ADC value of the voltage given, we use this formula. Your 3.3 is the maximum voltage of the cell, and this 4095 is the maximum ADC value equivalent to this. Okay. After calculating the ADC value, we again convert that ADC value into the voltage. Means we can know that how much voltage we are getting from the ESP32 ADC pin. So this is the code to detect the state of charge of the cell. So I'm coding in VS Code. You can also use Arduino IDE platform. So let's begin. This is the ADC pin declaration, that is pin number 34, and this is the void setup function. Here anything we write, it executes only once. So we have set the baud rate to 9600, and we have set the ADC range to full scale, that is varies from 0 to 3.3 volt. Okay, and here this is the function declaration, and this is the function void loop. Here anything we write, it continuously repeats in a loop. Okay, so we are storing the ADC value which we are getting from the pin 34, into this variable. Okay, and to convert that value into a voltage, here we are getting a ADC value as I told earlier, and to convert that ADC value into a voltage value, we use this formula. Since we have used the voltage divider with a similar resistor, that is 1k plus 1k, it divides the voltage by 2. So now to get the actual battery voltage, we have to again multiply the voltage which we are getting here again by 2. Okay, after multiplying the voltage, we print all these values, ADC value and voltage value and battery voltage. So coming to this function, SOC function. So we need to find the SOC, right? So we know that we are finding the state of charge by the equivalent voltage what we are getting. So simply we have written here an if-else ladder. If the voltage is greater than or equal to 4.2, then the state of charge must be 100%. Else, if voltage is less than 4, it must be 80%, and so on, 60%, 50%, 40 and 20. Okay, so we are calling the function here. As we know that the percentage is a float value, so we are calling it as a float. So after calling the function, we get the SOC and we are printing the SOC here. Okay, so let's dump the code and see what happens. First we are building the code. Code is successfully built. Now we load the code. The code is successfully uploaded. Now we open the serial monitor. Okay. Okay. Here we are getting the state of charge as 20%, 40%, even though the voltage is 3.5 volts. Okay, but we checked the voltage, it was 3.99 something. So we again need to multiply it by the correction factor. So you can see here the battery voltage we are getting 3.54, but the actual voltage was 3.90. So we need to multiply this voltage what we are getting by a correction factor. So I'll show you how we can get the correction factor. So the actual voltage 3.90, we divide it by what the voltage we are right now getting. So we will get that as 1.12 something. So we multiply with a correction factor of 1.20 to the actual voltage and again display it on the screen. So we are getting the actual values right now, as you can see here, 3.90 voltage, and the state of charge is 60%. Okay, that's it for today.